Hello, we are working on 5-5. I've made it to Austin, Texas, okay, checked into the hotel, going to do your video, and then hopefully get some sleep before I have to be at my conference at 7:30 a.m. in the morning. All right, so we have something a little new we're going to talk about, which is CPCTC, okay? That stands for congruent parts of congruent triangles are congruent. In other words, if you can prove that two triangles are congruent, then you can say anything about the triangles are congruent, angles or sides. So now we're going to go from proving congruent triangles to proving something's congruent about the triangles. So let's start up here at the top. And we're going to start by just naming off all the stuff so that are congruent. Let's go ahead and do the sides on this one, and we'll do the angles over here, okay? So the first side, we can say EF is congruent to HI. FG is congruent to IJ, and EG is congruent to HJ. All right, and then we can go over here to the angles. We can say angle E is congruent to angle H, angle F is congruent to angle I, and angle J is congruent to, why did I do that? How about angle G is congruent to angle J? Brain got ahead of itself. All right, so when using CPCTC, you can only be used after you know or prove that a triangle is congruent. For example, first you have to prove side, 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 angle, all those postulates and theorems. Then you can say it's congruent by CPCTC. Again, that's congruent parts of congruent triangles are congruent. All right, so let's go ahead and look at our first one right here. Our given is B is the midpoint of AE, and angle D is congruent to angle C. They've written it for us, isn't that so sweet? And we're going to put given. All right, so let's go see what that means. If B is the midpoint of AE, here's A to E, B is the midpoint, that means it cuts it in half. So A to B is congruent to B to E. I don't see that stated over here, so we're going to go state it. Side AB is congruent to side EB. And the reason is, look, they gave you a breadcrumb, is definition of midpoint. That's what made it work. Okay. Then they say angle D is congruent to angle C. So angle D to angle C. Can't state anything else about that. That's all we know is that those angles are congruent. So I've got a side and I've got an angle. Now I want you to think this is when you don't know which one you're going to use. But let's think of all the ones that have a side and an angle in them. We know that ASA, there's an angle and a side. We know that if we had side, angle, side, there's an angle and a side. Okay, side, side, side won't work. Angle, angle, side, that one would be a possibility. Okay, because you get an angle and a side. So outside of these two, you have to have another angle. On this one, you would have to have another side. And I don't really have any other information. There's no shared side or reflexive property. So I'm going to count this one out. But if I could get another angle, and so the first thing you look is for intersecting lines. And some of you's probably been saying, Miss Smith, there's vertical angles. And there are right here are vertical angles. Okay, so we can go ahead and state over here. Remember, you have to use 3 because angle B has more than one angle. So angle ABD is congruent to angle EBC. And the reason is definition of vertical angles. And so now you have angle, angle, side. So step 4 would be to say the two triangles are congruent. So triangle ABD is congruent to triangle, and be careful on this, you don't put C, but you put EBC. That is a B, people. Okay, and the reason for that is going to be angle, angle, side. Now we can go back and look what you want to prove, that side DB is congruent to side CB. So they're wanting to do this in a different color. I'm going to do it in pink. They're wanting to prove that DB is congruent to CB. And you can actually say it's now congruent. So we just write our proof statement. And the reason is because we've just proved that two triangles are congruent. When we know two triangles are congruent, we know all the parts. That means angles and sides are congruent. And so we just say that's congruent parts of congruent triangles are congruent. Okay, not so much talking in the next one. We got to move this along, people. Pause it, get it down. Let's move on. Okay, let's look at number 3. I'm going to let you work on number 2 on your own. Number 3, we have AD parallel to CB, and you have angle ACD is congruent to angle BCD. So let's go ahead and write that given statement right here for number 1. AD parallel to CB, and angle ACD is congruent to angle BDC, and our reason is given. Okay, so we have two parallels. We use arrows, so in other words, it looks like this. AD is parallel to CB. All right, and that actually gives us a little information. That means if we have parallel lines, I'm going to extend them so you can see them right here, and then you have this transversal that cuts through, you actually have alternate interior angles right here. So they're congruent to each other. And so we can actually say we have two sets. We have another set right here. These would be congruent to these. And so we can actually say on number 2 that, remember, we have to use 3 letters, that angle ACD is congruent to angle, so did ACB is congruent to BDC. And the reason for that is alternate interior angles. All right. For number 3, we could even take it a step further and we could say that angle ADC is congruent to angle BCD. And that is also, I should have put definition alternate interior angles, but for room's sake, I just put alternate interior angles. Okay, so we have an angle and an angle, and you should hopefully be recognizing oh, I did not want to do that. You should be recognizing the fact that you also have, I'm going to erase a little bit here, that you also have inside here, put my angle marks back on, you have this for shared side. So this side is congruent to itself. So for number 4, we're actually going to put DC congruent to DC, and this is by reflexive property. And I forgot all about this other one they gave us, which was ACD. So we actually don't need to state this one. That was an extra one I gave y'all. All right, so number 5, you actually know that these are now congruent. Oh, no, we don't yet. Angle, side, angle. I haven't written it. Boy, it's late tonight, people. So we have triangle ADC being congruent to triangle BCD. And my reason for that is my angle, side, angle. And on number 6, you can actually write the proven now. And the reason for that is CPCTC. Do y'all remember what that stands for? Congruent parts of congruent triangles are congruent. So basically, we have done up to now all those. All we're adding is one step. That's all we're adding to our proofs. So all these proofs you're doing are the exact same as what you've been doing in the previous lessons, except they're not telling you which one it is. Okay, once you figure that one out, then you're just writing one more that you're proving it's congruent. Okay, this video has gotten long enough. I'm going to let you go. Remember, there's a few ways you can contact me if you need help. Here's my email. How about I try to write that where you can see? I'm going to get used to this new pen. Okay, that's SESmith at caddoschools.org, or you can put some comments in on Google Classroom. I prefer you to watch these off Edpuzzle because then I can give you a nice, easy grade of 10 points over watching them off of YouTube. But if you can't get Edpuzzle to work on your phone, then please watch them off YouTube. All right, signing out. You guys have a fantastic Thanksgiving break.